Hello, hello. It looks like my mic is recording properly. Very cool. We're off to a non-technical difficulty start. Looking good. So welcome to the May Rust Gamedev Meetup. It says April there because I did not update my slides just yet. But we are indeed in May. And today we have quite a few cool projects to check out. Some cool people are going to be showing off what they've been working on. And so just quick introduction. My name is Forrest. I do a lot of open source development. I work on Valoran, which is a game in Rust. And because of this, I really like seeing the Rust ecosystem grow. And I really like seeing what other people are working on. And so I've started out this monthly meetup a few months back. And each month we meet up and kind of go over what kind of stuff we're working on. We have an opportunity to talk to other people who are working on some pretty cool projects and just be connected with the community as a whole. And so without further ado, we'll hop in right away with our first presentation here. All right, so first off, we're going to have Ekton and Daxpeta show off Cosmic Verge.
Cool. Unfortunately, I'm not going to be showing off Cosmic Verge, but I'm going to be talking more about the architecture. Last month when I was here, I kind of started talking a little bit about how we were going to replace Postgres and Redis with PliantDB. And we didn't quite get there in this last month. Got really close, but I didn't quite pull it off. And so we're going to talk a lot about the updates and some of the problems we're trying to solve, as well as the evolved architecture. So Cosmic Verge is a 2D, or it's going to be a 2D systematic sandbox MMO. It's completely open source. The game concept itself is very early in development, but I've been working on parts of it since 2019. Daxpeta joined us back in, or joined me really back in February. And since then, we've really been looking at trying to build a Rust first architecture and trying to solve problems right. He will be talking about some of our attempts at dealing with authorization and in a secure way. And I'm going to talk about all the other projects I've been working on. So here's the proposed Cosmic Verge architecture now. Previously, we had envisioned the idea that the client and the server of Cosmic Verge would talk together, and PliantDB would just be hosted kind of like Postgres or Redis normally would be, which is hidden behind a private network usually. After a lot of internal conversations, we decided to take an approach that ends up dogfooding PliantDB's architecture a lot. There's a lot of reasons to go into this, and unfortunately, I can't go into all of them right now. But we're really happy with the way this architecture is starting to come together in our minds. At the core of it, PliantDB is going to be handling all the network communications, and PliantDB is going to also offer a way to extend its internal API, networking API, with a custom API so that Cosmic Verge can build its own API kind of built on top of the cluster that PliantDB will eventually provide. Dax was working on looking at authentication. That's the custodian crate that you see there. Clugen and Cosmic Verge stuff hasn't been updated. That's kind of what the legend is meant to be showing you there. That's about it for the Cosmic Verge architecture. So let's look at PliantDB, which is much more complicated than it was last time. Previously, we just had Alachronic and Fabric behind the scenes. Fabric is our Quinn wrapper that is meant to just try to make it easy to get guaranteed reliable packet delivery out of Quick, which is a UDP-based protocol. And Alachronic is our goal of creating a async executor that supports multiple priorities so that we can have a lot more control over what jobs get priorities inside of our systems across our entire cluster. Since last month, I've added two new crates, which I'll talk about in upcoming slides, and I've already mentioned custodians, so we'll get to that in a minute as well. So one of the first big updates is adding PubSub, which is the ability to subscribe to topics and receive payloads based on those topics when they're published, regardless of whether or not you're on the actual server that was, actually had the messages published to. The API is very straightforward, as you can see, and it supports any serializable type through Cerde. This is the Circulate crate that I published. It's very lightweight. I'm not really sure if it's useful for third parties, but we're trying to make PliantDB very modular, and it made sense for this to kind of be its own little crate that PliantDB built on top of. We also added a key value store. The main motivation behind this is that the basic storage mechanism in PliantDB is ACID compliant, which unfortunately requires flushing to disk after every write. And that can be very slow, especially when you're trying to set things very quickly and over and over and over. Products like Redis will switch to a method where they flush to disk periodically. And that's essentially what the key value store is doing, is it's trying to provide high performance atomic operations in a way that basically you potentially could lose data between the last flush to disk. But it's kind of an industry standard for this type of thing. And when you need speed, this is kind of a good approach. So PliantDB is just trying to kind of solve each of the use cases that we've needed, why we normally would bring in multiple database products to solve these different problems. We're trying to put them all into one solution. The last thing that I was working on is permissions and the ability to define an API and allow those permissions to be automatically checked. That's the actionable crate, which is technically published, but all the vision that I told you hasn't actually been exposed in the published crate yet. I'm still working on some of the behind the scenes generic type handling to try to make it so that when you define one of your APIs through actionable, you can give it to PliantDB in a way that it knows how to handle. And I'm still trying to work through a little bit of that. Sadly, just wasn't able to get it done for today. The last things that I worked on with PliantDB mostly were with CI. So because I added all those feature flags and we wanted to keep things modular, I really needed to add a test matrix to make sure that all the feature flag combinations worked. There was also the code cov security breach, and I only have private or public repositories on there, but at the same time, I didn't love the idea of that issue. So I went ahead and migrated us away from CodeCov. So we're completely self-hosted with code coverage on GitHub pages now too. So for the rest of the presentation, I'm gonna hand it over to Dax, and he's gonna talk about what I consider a very important topic, which is keeping our secrets private.
Thanks. I'm going to preface this with I'm not a security expert, neither am I a cryptographer. That said, we are making a custodian right now, which is supposed to wrap all our security needs, or better said, authentication needs in one neat wrapper. So the problems that we're trying to solve is server-side password storage, which I think most here know, hashing and salting, very common thing to do. We are trying to not store any sensitive data on the client. This is mostly a feature that gets used when you use the Remember Me feature. We don't want to try to transmit any sensitive information over the wire. And in the best case scenario, the server actually never receives any sensitive data. And our solution for most of our password needs is the opaque protocol. I'm going to cover this on a very surface level because it's a really complicated protocol. So opaque is a protocol based on the APAKE methods. And so during registration, the password derives a secret that is stored on the server inside of the database. And during login, a shared secret between the server and the client is negotiated that's derived from that password and checked against the secret on the server. And all of that is happening without the shared secret or the password ever being transmitted over the wire. And so there's no sensitive data ever arriving to the server, nor is it transmitted over the wire. And there's two additions here that or two advantages that you get with opaque on top of that, and that is when the server secret gets leaked because of a database compromise or whatnot, you can't use that secret to actually impersonate the client, and the client can actually authenticate the server, because when you do the login with the shared secret generation and the server doesn't have the secret that was established during the registration, the client will notice that, and then it will know that the server is compromised or something else is wrong. This is the Rust implementation. This is not made by us, by the way. I want to also note that opaque and all APEC protocols are still in their infancy. APEC method is actually a very old thing. It was used like ages ago, but it never gained any traction until now. And Apple and Cloudflare are mainly pushing it. This is a quick overview of the threat model that Opaque is going to solve. So obviously, Opaque can't solve bad passwords or anything like that. It also can't solve if you have a compromised operating system. It can be used in the browser, but if it's trying to solve a compromised server, for example, it can't protect you against compromised servers, because compromised servers are just going to give you a spoofed website, and then they're just going to take away opaque or anything else that you're using. And but where you can use it is in your game, for example. In your game, if you have a login in your application and your server your server gets compromised, with opaque, you would immediately detect that there's something wrong with the server. And because there is no secret sent over the wire, you don't have to worry about your TLS. I mean, TLS is very, very safe, but your PKI system can get compromised. For example, your certificate leaks, or if you're using Cloudflare or AWS for your TLS termination, then these things can get compromised. Even if the companies don't get compromised, your configuration could get compromised. And so all of that is not a problem, because no secrets are sent anywhere. They're also not sent to the server or to the database or anywhere else. No secrets. So perfect. And the next problem that we want to tackle with Custodian is the Remember Me feature. And usually this is done with the operating system credential vault. And this has one big problem, and that is that most operating system vaults don't have any application level control. So that means that every application on your computer that has user privileges can access the secrets of every other application. And even if you give it a random name or anything like that, it can just enumerate through all secrets. So there is really no protection except on macOS on some level. And if you want application level control, then you have to use UWP on Microsoft and put your application on the Microsoft Store, or on the App Store on Apple, or on FlatHub, your Flatpaks on Linux, for example. But this will only protect against other sandboxed applications. So if there is a process, again, with user privileges, it can still access all passwords, except, again, on macOS. Browsers also use this for cookies, except, again, on macOS. And the issue with OS vaults in general, even on macOS, is that they are really just encrypted by the user password, by the operating system user password. And that's all the protection they get. And everything else is really just security theater, except on macOS. And we will come to that in the next slide, which is TPMs, is what macOS uses to make this more secure than other operating systems. And TPMs, just real quick, are just chips on your motherboard that can generate asymmetric certificates, or key pairs. And they can also sign messages with the private key without ever revealing the private key. That means it never gets into memory, it never gets access to the processor, or the operating system cannot get access to the private key. So it's basically just an isolated key pair store. And this is basically on every computer nowadays. So all Windows computers that were manufactured after 2016 have to have a TPM, otherwise they won't get certification. All Apple computers for a really long time now have TPMs. All phones have TPMs because they use ARM processors. So it is becoming ubiquitous. It's just a matter of time, really. There are software fallbacks on all operating systems, which is the OS vault mentioned above, with the same problems as above. And so the solution here is, instead of generating some session key to implement session persistence for Remember Me, you just generate a key pair on that TPM, register the public key on the server, and ta-da, you have session persistence without actually transmitting any secrets, storing any secrets insecurely, or do anything else. And then with that certificate, you use mutual TLS, so you just use it as a client certificate. Sometimes client certificates are not an option. For example, if you use Cloudflare for anything crazy, then you won't be able to use client certificates, and there are alternatives. You can just sign random messages and verify it that way. You can use security keys exactly like you use TPM. So if you have a YubiKey, for example, or Nitro key, you can use that. And there is even browser support incoming. Chrome has already support. I didn't verify if it actually uses TPMs or where it stores its stuff, but it has support. Firefox apparently has support, but it's bugged. I'm not exactly sure what the state is here, but it is definitely in the talks. One small thing that I think I forgot to say is servers can actually also use TPMs to just store your certificates if you want to. So that's great too. And here you can see just a quick overview of the threat model for TPMs and security keys. So obviously, because there is no secret that can get revealed, there are no issues with that. So the only issue that I can imagine is basically that if your client gets hacked and the attacker uses your computer to actually log in and do something, but he can't steal that authentication information because he can't get access to the private keys. So otherwise, there is no secret to steal because you can't get access to the private key. The private key is never transmitted to the server doesn't have the private key, nothing to be stolen, basically. There are some notes. TPMs can be hacked. There were hacks before, but they are mostly not through software, but physical attacks. You're actually going to have to steal the computer or the device. But I mean, generally speaking, they are tamper resistant. And for example, if you have an ARM processor like on phones, it's basically impossible to physically penetrate them and extract some keys. There are still computers without TPMs. If you have an older motherboard before 2016, mainly probably doesn't have a TPM. If you have a macOS, very, very likely that you have a TPM. TPM can be faked, which is usually not a problem unless an attacker hacked your computer and set up a fake TPM during registration, which is a very extensive, elaborate attack that you don't have to worry about. But there is a defense against that called TPM attestation, which is really complicated, and probably I'm not going to do that for Custodian. The Linux implementation has some room to grow, let's say. It works reliably, but there might be some server distributions out there that will not like how you access TPM. TPMs also don't really help with authentication. They really only help with session persistence. They're great if your users want to use client certificates for authentication, but that's really not a casual user thing to do. That's really for admins or people who are very IT aware. And we also have plans to put into Custodian support for biometrics. So that means Windows Hello, Touch ID, Face ID. We're also going to implement WebAuth support. That's probably the easiest of them all. And some support for secure enclaves, because they can also be used to store, generate, and sign messages with key pairs. That's it. Thank you very much.
Awesome. Thanks. And these are some quick links. I'll throw some in the chat. So thank you all for listening.
Awesome. Always super cool to hear where you're headed with some of like the back end systems in there. I think one thing I'm sort of wondering, so first of all, I love security. I love talking about it and kind of thinking about it. With these like type of like ways of sending like a challenge to the client and having them authenticate like that, what would it look like for clients who want to switch their account from one computer to another when their like their authentication method or their certificate generation is tied into that computer?
So is that for the feature of Remember Me, or do you mean like real authentication with the TPM?
Well, whatever the use case might be when it comes to like the game itself, I think.
Okay, well, for the game itself, I mean, we're really only going to use it for session persistence. We're actually not going to use it for authentication, except for example for Acton and me, because we are admins and we need some higher security for our accounts. But we're probably not going to use TPMs. We're going to use security keys. So you should, they're portable. You get them out of your computer and put them anywhere else. But yeah, I mean, that is definitely one disadvantage of using TPM as an authentication method. But as I said, we don't really plan to use them like this.
So the use case for the user is that when they go to log in, they will pick different methods for authenticating themselves. One will be a simple password, but will also have potentially OAuth as a way to identify yourself, as well as two-factor methods. And so various combinations will be able to authenticate yourself. And once you're authenticated, you'll be able to download a client certificate if you want to remember the session. Otherwise,
Hmm.
your session will just stay authenticated at the
Okay.
elevated permissions you got.
Yeah, yeah, super cool to kind of see like this sort of back end view into how you want to take care of it. So, anyways, thank you very much for showing off, and we'll move on to the next.
Yeah. Alright, can everyone see that? Yeah. So I'm Mikhail. I'm the first one actually to ever present it here. Alright.
All right, so next up we have Mikhail, who is going to show us off simple electronics.
Hey. So this is Simple Electronics. It's an electronic simulator, or more accurately, it's a digital logic simulator. Um, it's kind of along the lines of Logisim, if anyone's heard of that. And it just does digital circuits. So this is a half adder circuit, which is the core of like how you do arithmetic with electronics. So you can see there's two inputs, and if I turn them on and off, the outputs change accordingly. Um, so this simulator allows you to create different nodes. The GUI is created using eGUI, and there's some nice UI for placing wires and such. So if I want to add like another circuit down here, I can go and do that pretty easily. Um, one of the more interesting aspects of this from a game dev perspective is that I actually used like constant generics for the electronics graph or like the logic graph. Um, turned out to be kind of a bad idea because of how dynamic this all is, but it was cool to start out with. Um, So actually, that's what I wanted to talk about more. So I'm going to switch my screen share to the GitHub. All right, so if everyone can see my browser now, you can see that the repository is pretty basic right now. But I'm using macrocode, and um, I'm using specs for the ECS. So the electronics graph is actually represented as like a, a weird kind of constrainerics ECS model. Um, and every node consists of a few components. So you have the main node component, which is actually called connected, and node is a constraineric trait which has a number of inputs and outputs. So I use constrainerics because it kind of annoyed me when I was writing logic for each node, that you could have like a vector of inputs, and it kind of felt messy to me since you could have more inputs than you'd want, or vice versa. Um, and okay, this is actually not the file I thought I was in. So this is all right. Yeah, so this is the nodes file, which has all of the nodes. And by that I mean there's like an on node, off node, not node. And you can see that the logic for each of these nodes is pretty clean, I'd say. So for example, with an AND node, is defined as a node with 2 inputs and 1 output, and calculated state takes an array of 2 inputs and it outputs an array of 1 output. So you could have as many inputs or outputs as you want, and it'll just be passed as an array. And the input offsets and output offsets are just used for rendering where the connections actually attach. You can also see like on node has 0 inputs and 1 output, and it always just returns true. Switch node is interesting because it has state with it. Everything else is actually just like 0 sized, but switch node has state. And this can be addressed by like, clicking the node. In the future, I'm gonna add something like a signal generator, which will be pretty neat, I think. Um, so this actually worked really well. I was pretty happy with it. The only issue is that I have to have this all nodes macro, and you can see this all nodes macro actually just runs a macro on all the nodes. Um, and the issue with using a different type essentially for each node is that it doesn't work great with the ECS since I have to do a different system for each node and the macroing gets kind of complicated. So Kvark asked an interesting question, and he's correct basically because honestly I just wanted to do it because I wrote this the day after Consternerics was stabilized. So anyway, so for example, if I go to the rendering system, you can see that for every I can't find the system. Oh yeah, so every node has to have a different system, uh, and all of them are defined like with their draw function and phantom data. It's kind of a mess, but the main issue that I'm having now is that I want to add like compound nodes. By the way, it compiles to WebAssembly as well because of MacroQuad. Um, but I want to let people create custom compound nodes. So for example, I should be able to take the half adder circuit that I created before and like turn that into a compound node that I can place anywhere I want. But because the graph structure is kind of, it's like the whole ECS is one graph, it's pretty difficult to extract it. And also because Serta doesn't work well with constant generic arrays. Um, so I am still able to add like compound nodes. I won't have to completely redesign the architecture, but it does make it a lot harder, which is why I haven't finished it yet. Some other interesting aspects on the game dev side are that even though everything works real nice in MacroQuad for the most part, there are some aspects that you still have to kind of deal with. So for example, nothing is multi-threaded in WebAssembly. And I believe that it's possible to make things multi-threaded. I think WebAssembly does have multi-threading, but right now it doesn't. It just instantly panics if there's any new thread spawned. Another interesting thing is camera movement just doesn't work at all here. So if I try to move, okay, actually it does work, or well, it doesn't. So it works really cleanly when I run it on the desktop, but because of how the browser handles scrolling or something, it doesn't work out well here. And I believe that that's something that can be fixed pretty easily with like conditional compilation, but it's just an interesting thing that you have to like compensate for. Um, so that's everything I had to say.
Perfect. I think I have a few things that I'm sort of interested in. If I'm not mistaken, a few months ago you showed off Simple Physics, which was sort of like a similar
Yeah,
playground. And
yeah.
so,
So
or yeah, you go.
okay, now you can
Okay,
go.
I was gonna say, a lot of these seem like they have like a lot of like educational or potential when it comes to sort of playing around and exploring. And so, have you thought of tying like these different types of systems together, or like these different applications together to be able to create something bigger, or have you kind of thought where some of these might be able to go in terms of either making a game out of or making some type of tutorial or something out of?
Um, so Simple Physics started as actually my senior research project in high school. Um, and basically the goal, I started it before COVID even happened. But the goal was for teachers to be able to do like physics labs without having to buy equipment or for something with universal gravitation, you can't design a lab for that because we can't move around planets.
Hmm.
Well, not yet, but simple electronics is something I just came up with uh, a few months ago, and I kind of just tagged it on because I wanted to make it. So I am working with my physics professor actually to integrate it into class because he's doing like an online only physics class even after COVID is done.
Hmm.
Um, so I'm hopeful that I can develop something that will be used to actually teach students. I'm not sure where this simple electronics will tie in. I just kind of, stuck it on.
Yeah, I think it is a super cool kind of visual, and I think one of the things that I like most is as you're going through a circuit, you can sort of see time like or it takes time for things to happen, so things don't happen instantly, and then it gives you a bit more of an idea of what might be doing something in a different way than you'd expect. And so I think that's a
That's
pretty interesting visualization technique.
that's actually an interesting feature because it allows you to make clocks like this. This is how redstone clocks work in Minecraft, which I thought was funny.
Interesting. Yeah, because I guess
Um,
they're all on a beat too.
I also have to say that making the wires like animate like this is by far the most time I've spent.
Yeah. Yeah, I looked at that and I'm like, oh, I don't imagine that was easy. And maybe there's like techniques that you can do that will make it pretty trivial, but it still looked pretty great, I think.
Yeah.
All right, I'm just taking a look in chat and seeing if anybody has anything else, but I think that's it for questions. So super cool, and thanks for showing it off.
Do
Uh,
the animation style data races? Yeah, actually they do. So what you can do is reduce the frames per tick, and that makes it run instantly. Um, Ideally, I should allow it to run like many iterations per frame instead of the max right now is 1 tick per frame. But that's something to work on. All right.
All right, good stuff. All right, so next up we have Dmitry, who's going to show us Naga in GFX portability.
Hello, I'm Dmitry. We've been working in gfx community for a long time trying to build a pure Rust graphics stack. And I'd like to tell you more about one of the latest interesting things we got, such as Naga. Um, this is the big picture that we shared a while ago. It just shows that our graphics stack has a lot of moving components. And here in this talk, we're going to be interested in the left part only, to the left of WGPU. So gfx rs and what goes after it. One of the biggest missing pieces that we had for a while was shader translation. And everybody in the industry today depends on SPRV cross for generating backend shaders from SPRV. This is something we wanted to fix because SPRV cross is a huge dependency. It's complicated and it's slow. So we started writing our own stuff and we call it Naga. Architecture-wise, it's similar to LLVM, where there's multiple front ends, multiple backends. It can parse Wixel, which is the web GPU shading language. It can parse PRV, and there is support for GLSL, but it's a little bit in flux, so it's not recommended at this moment. When we parse stuff, we have a nice, tiny intermediate representation, which is called IR here, and we validate everything. So we guarantee that your shader code is safe in a sense that it's not going to access any memory it's not supposed to access, and every instruction makes sense. When the validator works, it also produces a piece of derived information from the IR, which helps to reduce work by the backend, such as like what is this type used for, what is the expression used for, and so forth. And we have a lot of backends. We can generate SPRV, metal shading language, HLSL and GLSL, and more to come in the future. This is the example of the metal shading language that we generate from the simple quad vertex shader. It's not super nice, but it's fairly readable and you can debug it. Now, one of the backends is Graphite, which is not a shading language. And I find it very helpful to reason about what intermediate representation has. So here's an example. This is the IR that goes into the Graphite backend, and it's getting this nice graph showing all the expressions, all the statements, how they're connected to each other, colors them, and you can cross-reference things from, say, error messages or just the source if you debug the intermediate representation or any of the passes we have on it. Naga is built in pure Rust. It's meant to be minimal. All the front ends and back ends are feature gated, so you don't enable what you don't need. And we have very small dependencies. Naga is designed to be cache friendly. We avoid repeating any computations. By cache friendly, I mean that all the data is stored in the arrays of structures. And when we iterate arrays of structures, we don't jump in memory back and forth. So the memory is extremely local. And all the algorithms that we do are asymptotically O of 1. So it's very fast. It's also, of course, it's safe, but not only it's safe, it's also not panicking. And I think it's hugely important because for a lot of applications, panic is very much undesirable. For example, one of the applications using Naga today is Gecko, so Firefox. When running your web GPU workloads, Naga is used to parse the Wixel shader. And if we panic during the parse because something went wrong, then user is going to experience a browser crash, which is definitely not something we want. So Naga is fully panic-free. It tries to return errors instead of panicking. It has a very minimal intermediate representation. As I explained, the backends need more than just intermediate representation. Like the backends need to know the type of every expression. And this is the information that we derive from the IR, which helps to keep IR itself very, very minimal. We have a small demo, which I don't know if it's going to run. We're going to try. So we integrated Naga into gfx-rs and gfx-portability. And the way it works there is that it parses the incoming SPRV, it does the minimal validation of that SPRV, and it produces the metal shading language source. I'm running this on a Mac. It is running a little bit slower than usual because we are recording this, but you can see that everything is rendered. You can go to heroes. So this is running the original Dota 2 on the pure Rust Vulkan portability implementation, which is gfx portability, without any use of SPRV cross. So it's loaded, and we can do everything. I'm gonna exit Dota and show some of the other results. You can see here, I recorded a few traces yesterday. So this is the trace that we have. This is the profiling integrated into GFX backend metal that captures the time spent in pipeline creation and shader compilation, and it routes it to Tracy. So if we're looking at the create graphics pipeline, for example, this is the path that uses SPRV cross in GFX portability, the old code. You can see it goes from 1 millisecond to 100 millisecond. The mean time is about 11 milliseconds with fairly big standard deviation. So that includes metal time spent inside creating the shader. If we don't want to include the metal time, we can look at the SPVC compile, which is about 4 milliseconds. Now we're going to load the trace that I recorded from Naga run. And the graphics pipeline, which was 11 milliseconds, is only 2. The times are much less spread over, so there is less of the deviation and less outliers in general. It's the pipeline creation basically works 4 times faster overall. But if we don't want to include the metal stuff, then we can just look at the how much time is spent on writing the MSL shader, and we're getting just 500 microseconds, which is again much faster than what we had there. We had there what 4 milliseconds, I think, or something like that. Naga does more work at the shader module creation. It is designed so that you can use your shader module many times, and even today, if you use the GLSL shaders to generate SPRV, then you may want to create multiple different graphics pipelines from the same shader because they may have different blend modes, for example. So you would reuse those intermediate computation steps a lot. But also, SPRV supports multiple entry points, which means you can use it even more. You can have a single shader module for the whole application if you want to. So that the part that parses SPRV is also like 400 microseconds. In total, the numbers we get is on average for the full stage. So from parsing SPRV to generating MSL, Naga spent about 1 millisecond. This is release build in Dota from Steam, basically. It creates something like 600 different graphics pipelines. So it's a fairly good average. At the same time, SPRV Cross spent more than 4 milliseconds on average on the same task. And SPRV Cross does not reuse the computations of the shader module. So the more you reuse the shader module, the more benefit you get essentially from this. I can imagine some applications can get up to 10x performance increase. So for now, we are seeing 4 times higher performance than SPRV Cross, and visually Dota still runs correctly. We are still looking at very small issues, but we are not concerned about any performance changes from year. So that's pretty much it.
Yeah, this is super cool to see. We have some questions here in chat. So first of all, how much can we customize and constrain validation? Can we measure instruction size to get some sense of the GPU load consumption? And then finally, can we measure memory consumption as well? And
Right.
by measure, they mean determine it during validation.
Yeah, validation in Naga is fully configurable. It has like 5 different flags to enable validation of types, expressions, and statements, and all of that. So it's all up to you to enable or disable if you want. For example, gfx-portability totally disables all the validation because the Vulkan is an unsafe API, and if you're not doing something correctly, it's your problem. But WGPU enables all the validation. I just got those CPU results from Dota a few days ago, so we haven't gotten into the GPU measurements yet. We definitely want to follow up with this. I'm also gonna publish a blog post explaining those numbers and the Naga progress on the gfx-rs blog, probably today or tomorrow. And as for memory, I'm 100% sure that it's going to be times less than Spear Cross. Again, we haven't measured it yet. Like all of our data is very, very tightly packed, and that's why we get the performance. So memory is not a concern here.
And then someone else mentions having such a significant performance improvement might get people to start using Vulkan portability to ship some Rust code in real games. And so I think so seeing the blog would be super cool and kind of learn about this. But do you see that this could be a place where a lot of games could get some really great performance improvements with very little work? Or what do you see as like the integration to getting it out in the wild?
Yeah, that's a great question. So on one hand, we will make a tiny wrapper of Naga that would expose a C API so that we can build a dynamic library and C applications such as Dota itself will be able to hook up into it and try it out if they want to. On the other hand, some of the developers consider this to be somewhat a non-issue. That is a controversial topic. So some of the developers think that just enabling the pipeline caching, and we have that. I just disabled that for this run because we want to know the speed of Naga. So pipeline caching can largely address this if you preload all the pipeline caches before the user starts the game. So at the same time, we see feedback from Raf, for example, you know him for Druid work, that they are concerned about the speed of shader generation. So for some people, it's very much a concern. For some people, it's very much not a concern. I imagine there is a portion of native C++ developers who would be interested to hook it up and see how it performs. Like in total, on my fairly weak MacBook Pro, it shaved off 6 seconds of the game. So I think it's good.
That's
Like
very
getting
significant.
earlier in the game, like why not? Who would refuse that?
Yeah, because so at first when you were showing these numbers, you showed that they were like very small. They are times improvements, but I think the big thing is like the magnitude of how many times you have to do this thing over and over. And so hearing that you're getting a 6-second performance difference, in practicality, that's amazing. That's super cool and super exciting to kind of see that this can be at the forefront of like these graphics technologies.
Yeah, I don't want to stress too much on this 6 seconds because it's a dirty number in the sense that it includes the metal work, and metal work very much depends on how warmed up the metal driver is. And I tried to warm it up for the Spear Cross multiple times, and it doesn't want to warm up as good as for Naga. So my understanding is that Spear Cross may be just generating more variance in the shaders so that like the driver cache cannot cope with that as good as with Naga's path.
I see. All right, so this is super cool. Drop some links in the chat so I can put them in announcements. And we have a lot more questions. I'll let you go and answer them in the text channel. But it's super cool to see this, and I'm excited to see where it goes in the future.
Thank you. It's all open source. Like you can find us easily. I'm gonna drop some links.
Okay.
All right, so next up we have Kevin and True Doctor, who are going to talk to us about Graphite.
Yeah, so we've got some updates from the last month. A lot of good progress that's happened since about a month ago.
So mainly we've got 3 new tools. We got the shape tool to generate basic shapes. Currently we have the hexagon. We can draw lines and also polylines. We also added some new constraints to the tools. So now you can draw ellipses and not just circles by not holding down the shift key. And you can also change the center position to either draw the ellipse from the center or from the bounding box you draw. And well, during the last Gamedev Meetup, we quickly hacked together a preview system that is now properly implemented with a whole new document backend, which is far more extensible. And we also have a layer system, which we can now even preview in the Graphite demo. And we also improved the render performance. We reduced the amount of heap allocations during each render cycle by about 10x, I think. So that was just a temporary fix and should be a lot better now. We also implemented a proper color system. This is currently only in the backend. We still need the color picker for the front end, but we've got all the basics down. And that also includes some additional Rust backend changes. We have modified some of the key handling. This is going to see some more changes over the next month. And we've also doubled the theme size, so please join us. And now back to Kevin for
Yes.
UI progress.
So here's some progress from last time. So this was a month ago. Things have been a slightly slower visual difference because a lot of the actual functionality has not gone into the visuals. It's gone into the functionality of tools and the ability to use the application. So now we can see that we have the layer panel on the right, and that displays the different layers that you've created, as well as a toggle for the visibility and things like that. A lot of the buttons you're seeing right now still are non-functional, but you can at least click on the tools on the left and draw stuff. This coming month, we are expecting that we should be able to hook up most of these buttons so they actually do things. Just for a quick comparison, last month and this month. And you can also see more about that when we show the actual demo in a minute. Additionally, I've been working more on the design. Specifically, this is the mock-up that I'm working on. It is not part of the code, but it is an important part of the process to make sure that we're creating a highly usable and visually appealing and enjoyable experience for people to use. So this was a last month, and then we've had some polishing since last month. So a month ago, and now we've added more buttons that will be the buttons that have. We've added more buttons as well as icons, basically, to the top bar and organize things. We now are going to be using Blender's approach. I'm not sure if you'll be able to see my mouse, but we have the design mode, and that is going to be basically in the way that Blender does edit mode and object mode and pose mode and different things like that. And weight paint mode will have different modes. Mainly it'll be design mode and mask mode, and that's how you'll be able to select things. Like you would normally select things in Photoshop using the marquee selection or the lasso tool. You'll use the existing tools, but you'll just do it in select mode, and that gives you a lot more power to use the full flexibility of every tool available to do your selection. Anyways, so we also have a new UI design system. So this was a lot of work, but it is an important step towards establishing what each of these components that we're going to be building, some of which are already made and some of which we still need to make. But this is a bunch of inputs that are all the different combinations between the different states of if they're just sitting there or if you're hovering over them or if you have them selected for all the different things. And then additionally, we've got all the buttons, all the layouts, all the different labels, different types of scroll bars. And we finally have a color system, and this is now standardized and shows its usage throughout the application. And now it's time for a live demo. So we have this running at editor.graphite.design. You are more than welcome at any time to go and open up editor.graphite.design and visit there and play with what is currently on master. So whenever we make a change, this automatically gets updated using our awesome new continuous deployment system that we set up. So you can draw rectangles, and you can see they get added over here when you draw them. You can draw lines, same thing. If you hold down Shift, it snaps your lines to 15-degree increments. If you're drawing a rectangle and you want to hold down Shift, it'll snap to squares. And if you hold down Shift and Alt, or if you just hold down Alt, it draws from the center instead of from the corner that you started at. And that's true for other tools. We've got Circle tool and the Ellipse tool, and if you hold down Shift, it draws circles from the corner, or circles from the center, or ellipses from the center. And also we've got our, currently just a hexagon tool, but this will be for any n-gon, and then eventually it'll also support stars and then more obscure shapes. You can draw from the center, from each corner. And yes, we've also got the pen tool. So this is what will become the actual pen tool, but right now it's just a polyline tool. This allows you to draw shapes, and then when you're done with it, you can hit enter, and it draws that polyline for you. We are also almost completely done hooking up the color system, but there will be a color picker that you can select between the primary and secondary colors. So these semi-transparent green colors will end up being your choice of the primary color that you select right here. And then we're also working on, in the next month, we should have it so you can scale and pan around using these plus or minus, or typing in your numbers here. And hopefully we should also have some of these other buttons hooked up. So yes. True Doctor, anything you'd like to mention?
I don't think so. The panel layer hiding thing doesn't currently work, and also you still have to press Z to delete to undo things.
Yes, we
But
can undo.
this is gonna change soon. We've got most things already implemented. Just need
Several bugs, but
finish
we
them
do
up.
actually have a lot of new issues on our GitHub repository. So previously it was a little bit starved of issues because we were too busy writing code and not busy enough actually filing issues. But now it's actually filled with issues, and you are more than welcome to come visit the issues page and actually just go and claim an issue and start working on them. Some of them are relatively small little bugs that you can investigate and actually fix, or small little features. Some of them are pretty accessible for new users, so I'd highly encourage you to come and be part of what will become the future of raster and vector editing for 2D.
Awesome. I always love seeing the updates on Graphite and kind of where it's going. One thing I'm sort of wondering
I'm
about,
very excited for how fast the progress is going.
it is quite amazing. When it comes to implementing some of like the more difficult features, and sort of like when I used Photoshop, what I assumed to be a difficult feature is like when I tried to drag around something and then it would be able to automatically detect where the lines I'm drawing are. So when it comes to like more advanced features like this, do you have much of a mindset on how you're going to approach it, whether you're going to have someone come in who just knows how to do it, or you're going to go out and look on how other software like GIMP or Krita might do it? Have you thought about
From
that
a
very
user
much, or
experience perspective, or from a
from a
an
development
architecture
perspective?
Yeah, basically every weekend we typically meet in the mornings, at least mornings Pacific time, evenings I guess for Europe. Seems that most of our team members actually happen to be in Europe. And we basically just sit down and have a topic and discuss the architecture that's involved for a particular feature. Some of the upcoming features that we need to work on now is a system for dealing with the way that you handle points. So you can actually drag around the individual vector points. So for example, you could take a square and then drag each corner around separately, and it would turn it into some shape instead of a square. That is one of the things that we have to work on next, and it does involve kind of a lot of systems and a lot of architecture involved in figuring out the best way of handling that cleanly, because we are building something that will become a huge application in the future. and it's necessary to have a good, clean code base from the beginning. Otherwise, it'll become increasingly hard to maintain and to continue adding features in the future. So that is
And
an
also
important consideration.
to add to your question about external help, there are some complicated things. For example, color management. We dipped our toes into it in some ways, but it's still a huge black box, and we would love to get any professional help to get
Yes.
it right from the beginning, because retrofitting a good proper color system is a pain.
Yes, it is difficult. Most applications, including Photoshop and others, really don't handle color amazingly. They do a decent job, but we want to have, we're kind of shooting for the stars with Graphite, and we want to have every possible useful feature that we can have. And that includes things like HDR colors from the beginning. It's not a retrofit, as well as color spaces of your choice, basically arbitrary color spaces. In fact, the entire editing process will actually be agnostic to its color space. So you'll be able to work with whatever color you want, and then the compositor will just deal with it and export in your final output format as you need it to be. So color is difficult, and color theory is a very complex task. But if you are familiar with it, please, please, please come join our Discord, and we have an entire channel set up just for color. So please help us out, as well as help us out with code or anything else. We do need some experienced front-end developers actually right now, if you have experience with that. Plus, there's also always room for additional Rust developers as well. We'd like to thank the most recent people to join the team this past month: Zero Hypercube, Edwin Chang, Norgate, and Furious. And also you, if you can join us. So please help us keep our doubling rate every month, end over end, or month over month. So yeah.
Perfect. So
Join us in Discord. That is, you can just visit graphite.design, and that'll bring you to the GitHub repository, and the GitHub repository has a section called Discord. So just join us there. Thanks.
Yeah, so definitely I'll drop all your links in the chat. It's always great seeing Graphite and seeing it grow, and so there's a lot of room for a lot of different people on team, and it's a super fast growing team, so do make sure to check it out if you are interested. We'll be back in just a sec to check out rafx.
Thank you.
It's amazing. It's absolutely amazing.
Yes, that is beautiful. I might have to steal that for the cover picture of the monthly meetup. I'm sorry, the monthly newsletter.
Is my microphone working?
All right, so next up we're going to be taking a look at rafx with Eclisma.
Hey everyone, this is an update on rafx for this month. The main things we added was a WebGL1 and GLES2 backend, and a new member, DVD, or David Von Duro. He's been working on a lot of he worked on visibility and a lot of the workflow for getting dynamic data from the game logic into the renderer, and that work is still ongoing. The first thing I wanted to show with the backend was with the new backend. So WebGL 1.0 and OpenGL ES 2.0, they're both almost the same API, almost identical. OpenGL ES 2.0, you're most likely to see that on Android devices that don't support Vulkan, which is about 50% of them, and about 10% only support up to ES 2.0. 2.0 is pretty old at this point, and but the reason I chose to support 2.0 was because WebGL itself, it supports 97% of browsers, but WebGL 2 only supports about 76, mostly because Safari on mobile and desktop require you to turn on an experimental feature flag to use WebGL 2. So this is just a quick demo of WebGL 1. It's basic, and there's a lot of features that are just never going to work in WebGL 1.0. but you can do some basic sprite drawing and you could make a game with this. Since then, and having learned a lot more about WebGL 1.0 and the limitations involved in it, I started also adding a ES 3.0 or WebGL 2 backend. And let me switch my screen. Is this visible? Great. This is not in a web browser. Yeah. Okay. Yeah. So this is the is not technically a new backend yet. I'm still just messing with it. The good thing is that porting, if you have an ES 2.0 renderer working, then getting an ES 3.0 renderer working is pretty straightforward. So most of the demos work at this point. You'll notice some shadows missing here, but it's good progress. And I imagine by the end of the month, we'll also have 3.0 running, which is good for phones. 3.0 does support quite a lot. The main thing it doesn't support is compute shaders. But I think one of the major issues with 2.0, OpenGL ES 2.0, I know this is word soup here today, but ES 2.0, it doesn't support proper handling for sRGB. So it kind of means you can't use PBR-based rendering. So, I mean, it's fine for 2D stuff and texture stuff, but yeah, I think most people doing anything in 3D are going to want to use WebGL2 or ES 3.0. Obviously, we still have our Vulkan and Metal backend, so this is more about adding compatibility. And also coming next month, DVD's been working on a lot of, as I said before, some improvements to the code for getting your game data into the rendering thread so that it can run in parallel with you simulating your next frame, which is a pretty industry standard thing to do. That's it for me. If you have any questions.
Perfect. Yeah, very cool to sort of see the updates here. I'm
No
trying to think.
questions?
Oh wait. Oh, sorry. Sorry, I forgot to unmute myself on Discord. I do this like half the time. I was talking on Twitch, but not to you. So super cool to see rafx. I think I don't see any questions here in the chat. What I'm sort of wondering about for myself is like, what are some of your goals? Like, so if you're able to support like a lot of stuff in the browser, is like the big goal to be able to just sort of be able to build anything that you can export to anywhere, or are you really trying to target the browser like as a first class citizen?
Well, I mean, I don't think the browser's, at least right now, the browser's pretty limited because you can't rely on anything but WebGL1 and ES2 to be available. So our main focus is going to be high-end rendering on native. But I'd say probably the biggest piece of feedback I've been given with rafx so far is that it doesn't support the web at all. So we wanted to stand up some basic support, and I don't expect that this is going to well, I don't think it's practical to target. If you make a game, I think you have to pick which backends you want to use and your feature set you want to target, because most people just aren't going to have the bandwidth to support gameplay that works well with what you can do with WebGL and works well with high-end desktop. So, but the nice thing here is that if you learn the API for one backend, you can broadly switch over to the other one. I just wouldn't expect you to be able to port a game easily from one to the other because of those limitations.
Now, we do have a few questions here. So first of all, how do you deal with features not supported by OpenGL-ES?
So, obviously compute shaders don't work in OpenGL-ES. So if you try to use an API that runs a compute shader, it will just panic or unimplemented because that's not supported. This is not intended to be a safe API, and it's expected that if you choose to use a backend like OpenGL ES 2.0, that you won't try to do things that are just not supported in the API.
Mm-hmm. And another one, what do you think about Rust GPU from Embark?
I think it's really cool. I don't mind GLSL and GLSL myself. I kind of like that it's a domain specific language. The main drawback with the domain specific language is that you have to maintain it. But the thing is, we've had stable standards for a decade, and while the latest newest thing usually, like, there's frustrating compiler errors that are annoying sometimes, but by and large it's stable and it works really well. And there's a lot of nice things you can do in a domain specific language, like swizzling a texture, that I'm not sure how that's going to be supported in Rust. And I think a lot of the things that people dislike about working in metal shader language, MSL, it's that way because they use C++ as the language for, like, they're trying to use an existing language for a shader.
Mm-hmm.
So I'm not sure how it's going to go to use an existing language like Rust for a shader and how it's going to be better than a domain specific language. But I'm really excited to see where they go with it. And I think it does have a lot of advantages, like being able to share code. And as far as getting that into rafx, as long as they're producing SPIR-V, which I think they are, then there's no reason you couldn't use that with rafx.
Nice. Yeah, I think
And
that's a
I
very
know
good
my
point.
opinion about the domain specific language is not going to be a popular, but yeah.
Yeah, I think everybody might do stuff a little bit differently, but I mean, I don't have too much insight into it myself. I haven't done too much graphics dev, but it's a very cool perspective to hear. And then finally, what's the performance like for 1 million sprite entities?
I haven't tested that. It should be good. We do sprite batching, so I don't think it's going to be any worse than you'd see anywhere else. Because I don't think there's a lot of sophisticated things. We don't do instancing, which I personally am not convinced that that's a good idea for quads. But I didn't try it either, so and maybe there's some advantage there. But the API does support instancing, so if someone wanted to do that, they could.
I see.
As far as the tile map goes, I mean, you can see this is. Let me switch it back. I mean, that's quite a few tiles, and this is in the GL backend, which is way slower than the Vulkan backend. So I don't think that someone the thing about the sprite entities question is how many pixels do you have? So how many sprites would you ever actually need to render?
Yeah.
Like if you've got 30,000, 40,000 sprites, you can cover the screen many times over with just 30, 40,000 sprites, which definitely does that at real-time frame rates. So
Awesome. Yeah, so I think that's pretty much it for questions here. So thank you very much for showing off, and we'll be back just in a second to take a look at color.
Hello. Thank you, Philip. Very cool graphics. Great stuff. Everyone should check it out.
So next up, we have Kay here, who's going to talk to us about color.
Yes, color. And I heard, I'm not sure if they're still here, but yeah, Graphite people mentioned color. And conveniently, we're going to talk about color management, color conversions. All right, color. So yeah, I started a journey earlier this year where I wasn't getting the colors that I wanted, or rather, I was putting colors in textures, and then I was expecting to see that color on my screen, and it was just never the case through a number of different applications. So I dove into it, and this is sort of the one approach to help alleviate that, and sort of it's been an exploration for me, but also hopefully this crate will be a useful tool for people that are looking to solve that problem of color management. So I think the problem with color a lot of times is like why people don't understand why they should care. sRGB, whatever they're doing, works fine. So that's going to be the primary thing I'm going to talk about, because you can, if you start to care, then you will read the docs and then you can go into the other things. Yeah. So why should we care about converting colors between color spaces, and why do we care about there being different color spaces at all? And you're if you're doing some kind of 3D game, you're probably using some kind of PBR or and HDR rendering and HDR. So yeah, your color pipeline probably looks something like you have textures that are made by artists, or yourself, you're also an artist. You have some uniforms from shaders or whatever, and those go into lighting, which is magic box depending on your engine. And then that goes into post processing. You probably do some color grading, like I mean the output of the lighting, so you get the scene color at some point once you've done that part enough. Then you get post processing. Then here you probably if you're doing some kind of more advanced game, you probably have color grading. Post processing might be things like bloom, anti-aliasing, things like that. And then you eventually get into tone mapping, so that you can send your colors to your monitor, because you have an HDR renderer. So HDR meaning your colors can go up to infinity essentially. So yeah, the problem is like what you put in here changes on the way here, on the way to the monitor. The colors that you've chosen, they will change in a PBR and HDR rendering pipeline, or at least all the ones that I've worked with, but probably not the way you expect it to. If you're using like out of the box tone mapping operators, being if you're using like a ASUS tone mapper, or some of the other more simple filmic ones that you find on the internet, you get some weird stuff. So oops, I don't know why this slide got duplicated. Sorry, I prepared this relatively quickly. So what's a tone mapper? It moves your RGB values from 0 to infinity into the 0 to 1 range, so that you can display it on a monitor, because the monitor expects values in the 0 to 1 range. And that's usually some sort of logarithmic function, towards the top, just to get some so you can see differences between values essentially. But it becomes very complicated once you get into the details. And the problem is if you use for example the ASUS tone mapper, as it's called, you can get things like this. So Frostbite had great presentations. I'm going to put some links at the end if you actually start to care about this. So Frostbite, the guys from Frostbite, Alex Fry, made a presentation talking about this issue where artists would, they'd author a color for their object, and you can see maybe here is this very sort of reddish hue on the wood, and then they could never get the color that they actually put in the texture. They would get a hue shift towards a more yellowish or something here, and you can see that the sky is just a different kind of blue. And the tricky thing about this is, right, you're still getting a blue. You're still getting, it kind of looks like wood. So people are kind of been accepting it over the years, but it's to me it's just, if you have artists in your team, and or you yourself, you care about having the right look in your game, then I think it's worth caring about, because you're the option here is basically you try to trial and error, pick a color value, test it in your engine until you get the correct hue, the hue you want, right? So yeah, this the tone mapper can change your colors basically. And if you look at, here's the UE4 ACES tone mapper implementation, and you can see that in the, this is a reference chart here on the right, that's color inputs, and then on the left you can see the outputs. Yeah, you can, hopefully the stream doesn't kill the colors here, but there are some significant weird things, like this purple here becomes super saturated and bright, and the orange completely loses, you know, it looks almost like a yellow. So some colors are affected more than others and can be quite a problem. Another source of error is in the pipeline. That's in the lighting. So we multiply in RGB for light bounces. You have an incoming light, you multiply the incoming light by the surface color to simulate reflecting light, basically. Or rather, you simulate how much light is absorbed versus how much is reflected. And when you multiply in RGB, it's a very rough approximation. And the result you see on the screen here is when you, like, it can happen when you multiply a orange thing with like an azure color in sRGB. The color vectors can end up in like pointing towards green, so you get a green. That's not great because this could never happen in real life. So yeah. But it doesn't have to be awful. This is another picture that still uses RGB multiplication, right? It's just using a different color space that's a bit wider than sRGB and a bit sharper in some terms that yeah, you will learn of if you start caring about this. So yeah, they are just trying to show like why you would care. Like you can get more correct results, and you can avoid very strange artifacts that you will just rip your hair out because you just can't figure out why. So now I'm going to get into like how do we represent colors in computers and where do these errors come from. There are tons of different color models, but color supports 3 component vectors, which means you know, 3 numbers that represent the color in some space. And all color spaces, they form some shape in the reference color space called CIE XYZ. And that one contains all possible colors, and it's derived from some experiments done in 1931 or something. Or maybe at least it was defined then. And so even if you have some color in, like, you know, you probably know about HSV or HSL, you probably know about RGB. There's a mapping of colors from those spaces into some kind of, you know, absolute color space called CIE XYZ. I'm going to show you what that looks like. So RGB, and excuse the extremely low resolution, I found this on the internet. This is the RGB color space, or, you know, if you have, imagine a cube with RGB, then you have the blue axis, the red, and the green axis, right? Pretty straightforward. This is what it looks like when you put it in the XYZ box, because there's a linear transformation between any RGB space and the CIE XYZ space. So yeah, you can see that, you know, when you have an RGB color, you basically get a vector from 0 here in this space, or the black point. Yeah. Oops. So you can imagine, you know, there are tons of billions of colors here, infinite number of colors in theory, but we classify it in you know, as humans, we probably can find most of the like chromas that we identify in this chart here, which is another color space called XYY, which is also supported by color, the crate color that I made. And this one is useful because it allows us to show sort of the range of colors that any color space can represent. I'll show you. So yeah, this is maybe a jarring difference here, but I just want to show you like all these different color spaces that have been defined over the years. So BT709 sRGB, they're the same thing as the red one here, the smallest triangle. That one is where, like, if you pick a color on your monitor, it's probably going to end up in that triangle somewhere. And there are a lot of colors that you just can't represent in sRGB if you would be very strict about it. Some of the wider ones here are to be like that today. Even the cheapest monitors can do more than sRGB. Maybe not perfect, but you know, some colors outside of this. And if you buy any sort of monitor for like $500 or something, then you will get quite good coverage of the green triangle here. There are monitors that stretch to the purple one here, but they are extremely expensive. Yeah, and you can see that XYZ is the triangle that covers the whole sphere, the whole space here. So if you would have been strict about displaying the colors as they were, this is, you know, just trying to show if you have a wider color space, you can get more vibrant colors. That's basically what it means. You can encode more vibrant colors. In practice, sRGB looks the same as these on your monitor. You're probably going to be like, but my colors don't look that muted, right? When I pick the reddest red, and that's because when your monitor gets, like, monitor manufacturers, they can display more saturated colors, but they, you know, and they want people to buy their monitors, so they sometimes treat sRGB values that you send to the monitor as like their color space. So they try to, like, if you give it like, oh, show me the reddest red, then your monitor will show the reddest red it can do, not necessarily the reddest red in sRGB space, which is an absolute color. That's supposed to be a very distinct color value that, you know, everyone can agree on in the real world. But when you send it to your monitor, the monitor is probably going to be like, I'm just going to show my reddest red. Now, if you output in sRGB and not a wider gamut, you are giving up control, because the thing is, if you would have given the monitor a wider space, then you get more control over which colors get displayed, because you can say, okay, I'm gonna display something in you know, this purple triangle here. So if I want to send the reddest red in the purple triangle, I end up in, you know, over here. But if I want to show the reddest red in the sRGB color, then it doesn't become like one in a value, right? It becomes a different value. So if you're using a wider gamut, you get more control over which colors you see on the screen. And sometimes that's good. It can help you like help artists be happier, because if an artist picks a color on like their super calibrated amazing color monitor, then they probably want exactly that color and not like a different one. And if that's the case, then, you know, you want to output in a wider gamut and make sure that you're trying to to convey the intent of the artist as well as you can into the final pixel that's being displayed. So hopefully that gives you some input into like why things are wrong and why you should care. I have some links here. I can probably put them in the channel later. There's if you want to care about this. So yeah, sorry. Now I just tried to convince you why you should care about it. So color is just a crate that tries to make it easy to convert between color spaces, and it supports more than any other crate in the ecosystem right now. It also works in WASM. So here's one example where I just did some kind of measure of color here and visualized it on a thing. I haven't had time to do too much. And then yeah, you can go visit either the repository where there's like a README, but most of the docs are on crates. So color supports a ton of different color spaces, and if you're just doing games, you probably don't care that much. But once you get into things like, okay, I want to do a proper tone mapper that keeps the intent of the artist better, then there are things like ICTCP here, which is useful. Now, color just has a few types, and the most important one is just color conversion, which it just converts from one color space to another color space. Very easy. And color space encapsulates any of the spaces that color supports. So it's a very data-driven API in that sense, and hopefully it will be useful to you. It can also help you to generate 3x3 matrices if you want to be doing these things on the GPU, which is very likely if you're doing game stuff. You probably want to check out the linear color conversion part here. So this is when you define a conversion between two color spaces, you get three parts. You get a nonlinear transform first, and then a linear part, which is a 3x3 matrix, and then you get another nonlinear part, and these might be optional depending on what kind of transform you're doing. But if you're going to be doing things on the GPU, then you can generate the matrix, like conversion matrix, on the CPU and upload it to your shader and do the thing. And then if you have nonlinear parts, then obviously we can't upload like the function for doing that thing. You probably need to go into some more details, and all of the details here are exposed as their own kind of functions. There's a lot of non-linear functions, like if you want to be doing like HSL and stuff, which is I don't recommend using these color spaces nowadays, but they're there. And you can just copy the implementation into your shader, port it to GLSL or whatever. It's fine. So if you want to be doing HSL code, you can just copy that implementation into your shader. Yeah, I mean, otherwise the crate is very straightforward. It's like if you want to be converting colors, you can do it. That's the only thing the crate does. It gives you this and lets you convert from one color space to another. The named color spaces are not the only ones supported. You can use anything that you saw the triangles earlier. You can take any sort of triangle that you can make up, and sometimes your monitor is like, oh, I have my own special triangle. Can you please output in this? And then yeah, you can make a matrix for that as well. At runtime, you don't need to code it in necessarily. But yeah, if you want to talk more about color or learn more, then I'm not going to cover that here. It's too much, but hopefully this gives you an idea of what you can do here and why you would care.
Yeah, I think that was a really cool overview of sort of a lot of the theory behind it, which is really great because I think anybody who's going to go into game dev will really not know too much about what's happening in the color, in the sense of like the artist will know what they tried to make and that is not coming out like that, and the programmer won't really understand the art enough to be able to like make it look as it needs to. And so I think this is a really great kind of overview, and then also just a project as a whole. And so we have a question that's pretty interested, or I'm pretty interested about, but like, what's the maturity of color of the project, and like how production ready is it?
I mean, it just does math, so I'd say it's pretty mature. But there are so there's one thing right now. It depends on it has one dependency. It depends on Glam to do math, which is a lot of people use it. But I suppose to make the crate more mature, we would probably copy in the few matrix functions that we're using into color, so we don't have any dependencies. But otherwise, I mean, I've tested it in WASM. It has no STD support if you're not looking for STDs. No, but if you don't want to use the STD library.
And then I think another one, so sort of like a maybe two-parter here. Does color provide shader code too? And then second of all, does it include the buggy Adobe PDF standardized blend functions?
No, okay, yeah. So that was two questions.
Oh yeah, sorry. The second one was more of a joke, I think. I'm not. Maybe it's not. I don't know. But
yeah, color doesn't give you any shader code right now, but I would love to like put shader code somewhere in the project just to help people, which seems like it would be a reasonable addition. So it's easy for people to just copy into whatever project they use, right? And blend functions, there are no blend functions in color. It only does conversions in sort of the XYZ space that I showed you. So it doesn't deal with rendering in temps and stuff yet. I might add support for more of that. And I mean, if you're doing blending, then you can probably just take a space and lerp between colors. That's usually what blending does. It doesn't do much more complicated thing than that. And for if you want to do a good gradient or something, then you probably want to use like OKLab, new space, and ICTCP. So OKLab, I can show you. You can just check it out for yourself in the future. But yeah, OKLab is this space made by Björn Ottosson, and he yeah, it just gives you better gradients, and it has a better prediction for lightness and that kind of stuff. So I think if you just Google OKLab, you get two primary links, and that's the interactive review of OKLab and the definition of OKLab lab itself. So yeah, hopefully that answered one question. Any more?
I think that's it from what I'm reading. But awesome presentation. Thank you very much.
All right. Thank you very much.
All right, so that's it for this month's Rust Gamedev Meetup. If you're looking to find out anything about the projects that were discussed today, hop onto our Discord. I have the announcements channel updated with everything that's there. We don't. I think we're looking at releasing the Rust Gamedev newsletter today or tomorrow, and so keep an eye out for that. Lots of cool updates in there. And then other than that, we will see everybody next month. Thank you for coming.